Picture this. You step into a massive, ancient stone chamber.
Oh, wow. Okay. Setting a scene.
Yeah, just go with me here. So the air is cool. It's heavy with the weight of thousands of years of history. You are standing right inside the center of a pyramid.
All right.
But as your eyes adjust to the darkness, you see something that just completely shatters that sense of antiquity. Hovering right there in the dead center of the chamber is this glowing, intensely luminous golden symbol.
Okay.
It's the Greek letter Phi. And it's not just, sitting there as a static image. It is intertwined with this spiraling, vibrating, standing wave of pure light.
Sounds like something out of a movie.
Right. It's pulsing with a rhythm that feels almost foundational, like you're staring at the actual heartbeat of reality itself.
It is an incredibly striking visual, and I think what is crucial to understand right from the beginning is that this isn't some piece of fantasy concept art.
No, it's not.
No, this is the explicit visual anchor for a highly technical, densely mathematical 2026 physics and engineering paper.
Exactly. So, welcome to today's deep dive. We are unpacking a massive body of work by George James Dukas. Specifically, we're focusing on a framework called the Transdimensional Unified Field Theory V2, or TDUFT.
TDUFT?
And we're zooming in on a very specific, wildly provocative mechanism within it, the standing phi wave on the 5-point pyramid wave.
Which is quite a mouthful.
It really is. And our mission today is to take this incredibly ambitious, dense theoretical framework and break it down for you. Because, this text is attempting to do nothing less than redefine the speed of light.
Yeah, redraw the boundaries of the observable cosmos.
Right, and even lay down a rigorous experimental framework for biological interactions.
Mm-hmm.
And it does all of this using a finite 5-node square pyramid model. It's a lot to wrap your head around.
It is. What's fascinating here is the complete departure from the geometry we are all so used to.
What do you mean by that?
Well, if you think about standard physics or standard cosmology, it is entirely built on the concept of continuous geometry. It's built on smooth curves, on perfect spheres, on circles. And because it is built on circles, it is fundamentally built on the mathematical constant pi.
Right, 3.14159 and so on.
Exactly. Pi is the language of our continuous universe. I mean, if you look at Einstein's field equations or the way we calculate the orbit of planets.
Or like electromagnetic waves.
Yes, exactly. Pi is everywhere. It assumes that space is a smooth, infinitely divisible fabric. But this text, it throws all of that out the window.
Which is a massive conceptual leap.
Yeah.
You're talking about throwing away a mathematical foundation that we've relied on since, the ancient Greeks.
Precisely. The author entirely discards standard continuous geometry. The paper explicitly argues that at the most fundamental level of reality, there are no circles.
None at all.
None. There is no continuous space to curve. Therefore, there is no pi. Instead, the theory models reality using a strictly discrete, finite structure.
Okay, so a grid.
Sort of, but very specific. It argues that the universe is made of just 5 points, which we call nodes, and 8 connecting strings, or edges.
Wow.
And the mathematical engine running this entire structure isn't pi, it's the golden ratio, phi.
Okay, I want to pause right there because we need to get our bearings before we start talking about how this applies to the speed of light or, the outer edges of the galaxy.
Right, the foundation first.
Exactly. We have to understand the fundamental shape of this proposed universe. Why a pyramid? And specifically, why exactly 5 points?
Well, to understand the physics of this model, you have to understand the stage the physics is playing out on. The shape is a square pyramid. Think of the most iconic pyramid architecture humanity has ever produced.
The Great Pyramid of Giza.
Yes. It has one apex node at the very top and 4 base nodes forming the square at the bottom.
Okay, so 1 apex plus 4 base points equals exactly 5 nodes.
Right. And the text points out this striking mathematical detail. This is the minimal discrete graph you can build that satisfies the symmetry requirements of the theory.
Meaning it's the simplest possible version.
Exactly. It is the simplest possible closed pyramidal structure you can make.
I want to play devil's advocate for a second here, or at least clarify something for anyone listening who is currently picturing the pyramids in Egypt.
Sure.
When we use the word pyramid in the context of this physics paper, are we talking about solid faces? Because when I think of Giza, I think of massive impenetrable walls of limestone blocks. Are we talking about a solid object with volume?
No, and that is a critical distinction that the framework makes repeatedly. We have to completely strip away the idea of solid faces or internal volume.
So if I can try an analogy here to see if I'm tracking.
Go for it.
Imagine you are going camping, right? And you unpack your tent. Before you throw the nylon fabric over it, you just assemble the poles.
The skeleton.
Right, you have the structural frame of the tent, the skeleton,
Mm-hmm.
but there are no walls. You try to touch the side of the tent, your hand just goes right through empty air.
That is a brilliant way to visualize it. The text strictly states there are no surfaces, no continuum, and no pi geometry whatsoever.
Just the poles.
Exactly. It is purely a network of connections, 5 structural nodes, and connecting them are 8 edges or strings. That's it.
Okay.
4 of those edges form the square base, connecting the 4 base nodes to each other. We call those the base edges.
Makes sense.
The other 4 edges reach up from the 4 base corners to meet at the apex. We call those the lateral edges. That is the entirety of the geometric universe in this model. 5 points, 8 strings, nothing else exists.
It honestly feels almost, I don't know, too simple. How on earth do you get the infinite complexity of the universe out of a naked tent frame?
You get it by recognizing that those strings are not all created equal. You get complexity by assigning very specific mathematical weights or values to those edges.
Okay.
This brings us to what the theory calls the additive side of the geometry. Every edge in this pyramid isn't just a dumb uniform line. It carries an intrinsic fundamental value based entirely on the golden ratio.
The golden ratio, which is represented by the Greek letter phi, roughly 1.618.
Yes.
You see it everywhere in nature, right? Sunflower seed spirals, nautilus shells, the proportions of classical architecture, even the branching of trees. It's famous for being aesthetically pleasing, but here it's being used as hard physics.
Here, it is the fundamental currency of the underlying geometry. The text assigns specific formulas to the edges.
Okay, let's hear them.
The 4 lateral edges, the ones reaching up to the apex, each get a geometric weight of phi to the power of -1 divided by 4.
Okay, phi to the -1 divided by 4. I can visualize that as a fraction.
And the 4 base edges, the ones making the square on the ground, each get a weight of phi to the power of -2 divided by 4.
So phi to the -2 over 4.
Right. Now, if you look at the additive math here, the text is this beautiful bit of accounting. If you sum up all 4 lateral edges, you are just multiplying phi to the -1 over 4 by 4, which gives you exactly phi to the -1.
Oh, I see where this is going. And if you sum up the 4 base edges, you multiply phi to the -2 over 4 by 4, which gives you phi to the -2.
Now, here is the magic trick of the golden ratio. By its very mathematical definition, what happens when you add phi to the -1 and phi to the -2 together?
It equals exactly 1.
A perfect integer. The total geometric weight of all 8 edges combined
The entire structural frame of the pyramid.
sums up cleanly and perfectly to the number 1.
That is deeply satisfying math.
It is elegant. But the geometry isn't just the edges. We can't forget the nodes.
Right, the 5 points themselves.
The nodes themselves, the 5 points where the strings meet, have what the text refers to as a nodal self-energy. The text defines the total intrinsic trace value of those 5 nodes as exactly 2.
Let me make sure I'm following the arithmetic. We take the 1 from the collective weight of the 8 strings. We add the 2 from the collective self-energy of the 5 nodes, and we arrive at the number 3.
Yes. The text defines this as G subpyramid equals 3. That number 3 is the total additive geometric content of this entire 5-node universe.
Wow.
It is the absolute geometric foundation of the model. In this framework, the raw, unmoving structure of reality sums perfectly, without any messy decimal places, to the number 3.
I love the elegance of that, but, you know, a static tent frame doesn't do anything on its own.
No, it doesn't.
Like a silent guitar string doesn't make music.
Mm.
To get a dynamic universe, to get something like the speed of light traversing across space, that structural frame needs to move. It needs some kind of energy. It needs to vibrate.
And that transition from a static frame to a dynamic vibration is the entire crux of the theory. The static geometry adds up to 3, but reality isn't just geometry sitting still in the dark.
Right.
Reality is geometry interacting with waves.
Which brings us to perhaps the most mind-bending part of this entire paper, redefining the speed of light. I have to admit, when I was reading through the source material, this is the section that made me stop, put my coffee down, and reread the page 3 times.
It's a heavy concept.
It really is. We all know the speed of light. It's c. It is the ultimate speed limit of the universe. In standard physics, from high school science classes all the way to advanced astrophysics, the speed of light just is.
It's a fundamental constant that we measure.
Exactly.
Yeah.
It's a given property of the cosmos. But this text argues that c is not a fundamental cause. It argues that c is an effect. It is a byproduct. And the author introduces this incredibly bold, central equation to prove it.
The central equation of the TDUFT model is written as C of 1s divided by 10 to the 8th equals 3 minus s subwave.
Okay, let's break that equation apart piece by piece, because there is a massive conceptual leap happening in those few symbols. Let's start with the left side. What exactly does C of 1s over 10 to the 8th actually mean?
The text is taking the commonly accepted speed of light, which is roughly 299,792,458 meters per second. But meters and seconds are human inventions. They are arbitrary units based on the size of our planet and its rotation around the sun. The universe doesn't care about meters.
Right.
So the equation divides the speed of light by 10 to the 8th. This strips away the human units and simply shifts the decimal point, leaving a pure, dimensionless number.
So instead of 299 million meters per second, we are just looking at the absolute numerical value, 2.997924558.
Correct. It is a pure ratio now. Now let's look at the right side of the equation. It reads 3 minus s subwave.
And we already know where the number 3 comes from.
Exactly.
That is G subpyramid, the total additive integer of our 5-node geometric tent frame.
Yes.
So if I'm reading this right, the pure dimensionless numerical value is the speed of light, 2.997924558, is mathematically equal to the raw structural geometry of the universe, which is 3, minus this variable called s subwave.
You've got it.
What on earth is s subwave?
A subwave is defined as the multiplicative standing wave coherence. Remember how we said the static strings add up to 3?
Yeah.
Well, the standing wave is a vibration that multiplies as it propagates across those exact same strings. The text describes it as an active vibrating energy that exists on the lattice. It creates a coherence correction.
Let me see if I can find a better way to visualize this.
Yeah.
Earlier, I was thinking about a sculptor carving marble. But thinking about it more, that implies someone chopping away matter. Since we are talking about waves, let's use an acoustic analogy.
I like acoustic analogies.
Okay, imagine you have a high-end guitar. The raw materials, the wood, the precise length of the neck, the tension of the unplucked strings, that is your geometry. That is your baseline state, your integer of 3.
Right.
But you don't want raw materials. You want a very specific, perfect musical note, say a perfect A-string resonance. To get that, you pluck the string. You introduce a standing wave.
Okay, I see where you're going.
As that wave vibrates back and forth across the finite length of the string, it creates interference patterns. It self-corrects. The physics of the vibration slightly alters the effective state of the instrument. It's like the standing wave tightens the pitch, just a microscopic fraction of a hair, pulling it slightly down from the raw geometry until it locks perfectly into that pure crystalline note.
Oh, that's good.
And in this universe, that perfect resulting note is the speed of light.
That is a phenomenal analogy. The raw geometry is the instrument. The S subwave is the harmonic vibration. And when you subtract the effect of that vibration from the raw instrument, the resulting pitch is 2.997924558.
Which means we can actually calculate exactly what that vibration must be. If the left side of the equation has to equal 2.99 roughly, and the base geometry is exactly 3, then the math absolutely demands that the standing wave, S subwave, must be the precise difference between those two numbers.
Exactly right. To balance the equation, the multiplicative standing wave must equal 0.002075542. The model proposes that the speed of light is not a random number God threw at a dartboard. The speed of light is the inevitable physical consequence of a specific phi-weighted standing wave vibrating on a 5-node geometry.
That completely shifts the paradigm. It makes the speed of light an emergent property of geometry and resonance rather than a fundamental pillar.
It really does.
But how does this wave actually move? How does it behave? Because the text doesn't just give us a simple subtraction problem and walk away. It dives deep into the underlying mechanics. There is some intense, frankly intimidating calculus in these sources.
There is. The text provides a very complex visual of what they call the candidate master operator. It is a mathematical engine designed to show exactly how this standing wave exists and changes.
I remember looking at that equation. It's a beast.
Yes.
It's written as a partial differential equation, or a PDE. It shows the time derivative of the resonator state, which they denote mathematically as d to the n of xt. It's full of nablas, partial derivatives, Greek letters I haven't seen since college.
It can be overwhelming.
For the listener who might not look at advanced calculus every day, can you break down what this equation is actually trying to tell us about reality?
Sure. A partial differential equation is simply a way to describe how something changes across multiple variables at the same time. usually how something changes over physical space and how it changes over time. Let's isolate the three key components of this specific master operator.
Okay. So it's
First, the equation includes acoustic psi waves. In this context, psi represents the actual physical vibration, the mechanical energy traveling through the medium of the strings.
okay, the vibration itself. Got it.
Second, it features a phi gradient. A gradient is a mathematical rule that points in a specific direction.
Like a flow.
Exactly. This phi gradient enforces the rule that the wave cannot just slosh around randomly. It must navigate the lattice strictly according to the golden ratio proportions we discussed earlier. It forces the energy to flow along the phi to the -1 and phi to the -2 pathways.
Okay, so we have the vibration itself and we have the traffic cop forcing the vibration to follow the golden ratio. What's the third component?
The third and perhaps most mysterious component is the inclusion of zero-point kappa terms.
0-point kappa terms. I know 0-point energy is a buzzword that gets thrown around a lot in sci-fi. What role are they playing in this hard physics equation?
Well, in quantum mechanics, the vacuum of space is never truly empty. Even if you remove every atom, every photon, and cool it down to absolute zero, there is still a baseline level of quantum fluctuation, a boiling sea of potential energy.
Right, the background fuzz.
That is the zero-point field. The kappa terms in this equation represent the interaction between our perfect mathematical standing wave and that messy, boiling baseline energy of the vacuum.
Oh, I see.
The master operator equation is attempting to govern how the standing wave's coherence evolves, how it fights against the drag of the quantum vacuum, and most crucially for our next topic, how it attenuates or fades over time as it moves through the lattice.
Which brings up a really intuitive question. If you were listening to this, you might be wondering, if the speed of light isn't a photon rocketing through a completely empty void, but is instead just a harmonic vibration rippling across a geometric lattice of strings, what happens when that wave has to travel across vast cosmic distances?
Exactly.
Does the vibration eventually run out of steam? Does it fade?
And that takes us directly into the cosmic implications of this theory. Because if light is a vibration on a finite, discrete graph, the entire concept of distance completely changes its meaning.
I want to make sure I grasp this difference. In standard physics, if I turn on a powerful laser and point it into deep space, that photon just travels through the continuous vacuum forever.
Assuming it doesn't hit anything, yeah.
Right, assuming it doesn't hit a cloud of dust or a planet, it just keeps going. The space it travels through is continuous and smooth.
But in the TDUFT model, distance is not continuous empty space. Space is pixelated. Distance is a discrete series of edge traversals.
Like hopping stones.
Yes. It's the wave hopping from string to node to string to node across the pyramidal lattice. And here's the catch. Every single time the wave traverses an edge, it multiplies the remaining coherence by a transmission factor that is slightly less than 1.
So it's like a cosmic game of telephone. Every time the signal is passed from one node to the next, it loses a tiny, tiny fraction of its original fidelity.
Precisely. It is a discrete edge sum. It is a finite product of transmission factors. Because the wave is constantly multiplying by a fraction slightly less than 1, the coherence of the wave exponentially decays the further it travels through the lattice. The vibration literally exhausts itself the more hops it has to make.
Let's unpack the reality of this for the listener, because this is where the theory hits observable astronomy. If you look up at the stars at night, you are seeing light that has traveled vast distances.
Right.
If light fades out just by the sheer act of hopping across the lattice, does that mean there is a hard physical limit to how far away a star can be before its light simply vanishes into nothing?
Yes, and the model explicitly calculates this limit. It defines what it calls a solar blackout radius.
Solar blackout radius.
This is the absolute maximum distance at which the specific intensity of our sun could be detected by any instrument anywhere in the universe before the standing wave loses so much coherence that it essentially flatlines into the background noise of the zero-point field.
How do they even begin to calculate a blackout radius for our sun?
They start with the sun's effective temperature, which is denoted as T sub F equals 5,772 Kelvin. They feed that baseline power into their source power scale.
Okay.
Then they apply the geometric coefficient of 3, because the raw geometry of the lattice is always 3, and they use that master operator equation to calculate the exponential decay of the wave coherence hop by hop.
So it's pure math.
Pure math. The result is a hard mathematical boundary. Beyond that specific blackout radius, the sun is completely undetectable. Its light hasn't stopped in the traditional sense, but its coherence has attenuated to absolute zero.
So from the perspective of an alien observer sitting just 1 mile outside that blackout radius, looking back at our solar system, our sun simply does not exist visually.
It's gone.
It's not just dim. It is completely blacked out. The signal has degraded to zero. And what's fascinating is that the text doesn't just calculate this for our local star. It points this math at the absolute edge of our known universe. It applies this lattice attenuation to a specific, incredibly famous high redshift galaxy known as MOM Z14.
Yes, MOM Z14 is a perfect test case. In standard cosmology, observing through telescopes like the James Webb, this galaxy has a spectroscopic redshift of 14.44.
Which is huge.
In the standard model, redshift is an indicator of velocity and distance based on the expansion of space itself. It makes MOM Z14 one of the oldest, most distant objects humanity has ever observed.
And standard models use something called luminosity distance, right?
Yes, within an expanding universe framework, specifically the lambda CDM model, to calculate how far away it actually is and why its light is so stretched out by the time it reaches our lenses.
But if you throw away continuous geometry, you throw away lambda CDM. So the TDUFT model must approach MOM Z14 completely differently.
Entirely differently. The text calculates a detectability radius for MOM Z14 based purely on wave attenuation across the Phi lattice. It ignores the expansion of space. Completely. Instead, it assumes a maximal coherence state, essentially asking, if the wave travels as perfectly as possible across the strings, what is the absolute upper bound limit where an object of MOM Z14's massive power output could still register a single photon on our telescopes?
I want to make sure we highlight a crucial distinction here, because it's very easy for someone casually interested in astronomy to get this twisted. When standard cosmology talks about the edge of the observable universe, they're talking about a causal horizon.
Right.
They're looking at the Big Bang, looking at the age of the universe, about 13.8 billion years, and saying, light from beyond that point simply hasn't had enough time to reach us yet. The universe might go on forever, infinitely far, but our vision is restricted by the age of the universe and the speed limit of c.
Exactly right. Standard cosmology says the horizon is a factor of time and the stretching of space. But the TDUFT model is saying something radically different.
What's it saying?
The blackout radius is an upper bound of instrument detection based on wave attenuation. It has absolutely nothing to do with the age of the universe or the limits of causality. It is purely a mechanical limit of the medium itself.
That is wild.
The light from a galaxy further away than MOM Z14's blackout radius might have had trillions of years to reach us. It might be shining incredibly brightly right now, but it doesn't matter because the actual harmonic vibration of the light wave simply wore itself out, grinding down to zero after traveling across too many lattice edges.
It's the difference between saying the road to the next city hasn't been built yet versus the road is there, but your car ran out of gas.
Perfect analogy.
In this model, the light simply runs out of coherence gas. It's a staggering way to reimagine the cosmos. It implies the universe could be infinitely old and infinitely large, but we are just trapped in a bubble of local visibility dictated by friction on a mathematical graph.
It is a humbling thought.
But here is where it gets really incredible. We aren't just going to leave this as abstract cosmic math. The authors of this text don't just want to philosophize about the edges of the universe. They make the claim that you can actually trap this exact dynamic on a workbench.
Yes. This is where the paper shifts gears dramatically, moving from theoretical physics and cosmology into hard electrical engineering. It details the building of the pyramidal coherence device, or the PCD.
The PCD.
The underlying claim here is profound, because this theory is built on a finite, scale-independent graph, just 5 nodes and 8 edges. You don't need a galaxy-sized laboratory to test it.
Because the math doesn't scale.
Right, the math doesn't care if the nodes are light years apart or millimeters apart. You can build the exact same geometric lattice and capture the exact same standing wave on a standard printed circuit board.
We are moving from cosmic equations to a literal PCB that you can hold in your hand. How do you translate a theoretical tent frame in the vacuum of space into physical hardware?
Well, before you even pick up a soldering iron, you have to know what you are looking for mathematically. The text explains that the physical device must exhibit a very specific electromagnetic fingerprint.
A fingerprint.
Because it is a 5-node system, the mathematics of graph theory demand that it must produce exactly 5 resonant modes. But it's not enough to just find 5 random frequencies of vibration. The spatial patterns of how the energy moves, what we call the eigenvectors, have to match the theory perfectly.
Okay.
There are 4 distinct modes or wave patterns you have to successfully identify to prove you've built the pyramid correctly.
Okay, let's walk through this fingerprint. Imagine our 5 nodes, 1 at the top, 4 on the base. What does the first mode look like?
The first is the common phase mode. In this state, all 5 nodes, the apex and the 4 base nodes, move perfectly together in total sync. They rise and fall in electrical potential as one continuous unit.
That makes intuitive sense, like a boat rising and falling on a single ocean swell. What's the second pattern?
The second is actually a pair known as the dark mode doublet. This one is fascinating from a physics perspective.
Oh, why is that?
In this mode, the electrical energy is sloshing around the 4 base nodes in such a specific rhythm that their amplitudes perfectly cancel each other out by the time the energy reaches the apex. It is total destructive interference.
I love that visual. So you have an absolute storm of energy swirling around the base of the pyramid, but if you measure the peak, there is absolute dead calm. It remains perfectly still. It is electrically dark.
Exactly. That accounts for 3 of the 5 required modes. The fourth pattern is the quadrupole mode. Here, the apex is once again still, but the base nodes alternate in phase. Node 1 goes up, node 2 goes down, node 3 goes up, node 4 goes down. It creates an alternating, spinning ring of energy on the square base.
And finally, the star of the show, the fifth mode.
Yes, the bright pyramidal mode. This is the critical mode because this is the one that most strongly expresses the coherent standing wave across the entire structure.
Okay, what does it look like?
In this mode, the 4 base nodes all move exactly together, perfectly in phase with equal amplitudes, but the apex node oscillates exactly opposite to them.
Like a counterweight.
Right. When the entire base pushes energy up, the apex pulls energy down. When the base pulls, the apex pushes. It is a complete dynamic standing wave stretched across the entire pyramidal lattice.
Okay, so that is the theoretical fingerprint we need to find on our oscilloscope. Now let's talk about the actual hardware. How do we build the nodes and strings? The text gives us the exact requirements to build an RF, or radio frequency, LC prototype. For those listening who might not build circuits on the weekend, an LC circuit is a foundational electrical resonator. It is made of 2 components, an inductor, which stores energy in a magnetic field, and a capacitor, which stores energy in an electric field.
Right.
When you wire them together, the energy bounces back and forth between the magnetic and electric fields. It creates a natural resonance. It's exactly like pushing a pendulum and watching it swing back and forth at a steady rhythm.
That's a perfect explanation of resonance. To build the 5 structural nodes of our pyramid, the text specifies using 5 perfectly matched 10 microhenry inductors, paired with 5 100 picofarad capacitors.
10 microhenry, 100 picofarad.
But you can't just buy them and slap them together. Physical components are messy. You have to trim and tune these components carefully so that before you wire any of them together, all 5 isolated nodes ring at the exact same bare resonant frequency.
What's the frequency?
In the paper's prototype, that baseline frequency works out to about 5.03 megahertz.
So we have our 5 isolated points humming away at 5.03 megahertz. Now we have to build the edges, the mathematical strings, and we do this by adding more capacitors to link the nodes together.
Yes.
To mimic the geometry, we use specific values. For the 4 base edges, connecting the base nodes into a square, the text uses 2.2 picofarad capacitors. For the 4 lateral edges connecting the base nodes up to the apex, it uses 3.6 picofarad capacitors.
And here is where the theory and the hardware collide. If you divide the lateral capacitor value, 3.6, by the base capacitor value, 2.2, what do you get?
You get approximately 1.636.
Which is incredibly close to 1.618, the golden ratio, phi.
I see. But wait, close isn't perfect. 1.636 is not phi.
And the text is painstakingly clear about that exact issue. Just soldering those rough capacitors onto a fiberglass board is not enough. The physical components have manufacturing tolerances. The copper traces on the board have parasitic resistance.
Real-world problems.
Exactly. The physical gap between components is not the same thing as the abstract mathematical graph weight. You cannot just trust the labels on the capacitors.
So what do?
You have to measure the effective coupling rate by looking at how the electrical frequencies split when the nodes exchange energy. You have to manually, painstakingly tune the device using variable capacitors until the measured lateral coupling divided by the measured base coupling equals exactly phi.
Okay, let me push back a bit here. Because building a 5-node circuit isn't inherently special. I could go to an electronics store, buy random resistors and capacitors, and solder 5 nodes together. The device will resonate. It will do something. Why is hitting Phi exactly so vital?
You are absolutely right. A random circuit will do something. But doing something isn't proving a unified field theory. The core test, the absolute make-or-break moment for this entire multidimensional framework, is what the text calls the Phi advantage hypothesis.
Let's unpack this hypothesis. What exactly are the authors claiming happens when you tune those little knobs and hit that perfect 1.618 ratio?
The hypothesis claims that when, and absolutely only when, the effective coupling ratio is exactly Phi, the device will exhibit a sudden, measurable, quantitative advantage in 2 specific areas: mode isolation and perturbation resilience.
Meaning the modes, like that bright pyramidal mode we talked about, will suddenly become cleaner, sharper, and dramatically more distinct from the background electrical noise.
Yes, and perturbation resilience means the wave becomes incredibly stubborn.
Stubborn how?
If you bump the table, or introduce thermal noise, or try to slightly detune one of the nodes, the standing wave won't shatter. It will dynamically self-correct and hold its geometric shape. The golden ratio acts as a mathematical anchor, locking the electrical wave into a state of hyperstability that shouldn't be possible in a normal circuit.
But in hard science, you don't just prove you are right by showing your device works once. You have to prove that it doesn't work when you take away your special ingredient. How do they prove it's the Phi ratio doing the work, and not just the fact that it's a well-built circuit?
This is where the text demands an incredibly rigorous set of null tests. It lays out the scientific method flawlessly. You have to build the perfect Phi ratio device and measure its high stability score. But then, keeping the total energy running through the system exactly the same, you have to physically change the structural ratio.
How so?
First, you build an equal coupling control. You change the capacitors so the lateral and base lengths are exactly 1-to-1. Does the system lose its magical stability? Yes or no?
Then you build a random coupling control, right? You scramble the capacitive values completely, maintaining the same total voltage across the board,
Right.
but destroying the pyramidal structure entirely. Does the bright pyramidal mode vanish into noise? Yes or no?
And my personal favorite, the broken pyramid control. You take the perfect Phi ratio circuit, it's humming along beautifully, and you literally snap one of the lateral links.
Just break it?
Just break it. You break the mathematical symmetry. The text demands you measure what happens. Does the dark mode's perfect cancellation immediately collapse, causing the apex to suddenly flood with chaotic voltage?
You have to prove undeniably that the hyperstability is derived exclusively from the Phi geometry and not just from having a bunch of copper and capacitors wired together.
Exactly.
The rigor there is incredibly satisfying. And it's worth noting for the listener, the text makes it very clear this isn't just a quirk of printed circuit boards. The underlying math is completely platform agnostic.
Completely. Because the math relies on discrete graph theory, the medium doesn't matter. You could build this in optics using 5 microscopic photonic rings exchanging laser light. You could build it in macroacoustics using 5 physical weights vibrating on tuned mechanical springs.
Even quantum computers.
Yes, you can build it in a cryostat near absolute zero using 5 superconducting qubits exchanging microwave photons. As long as the graph is 5 nodes, 8 edges, and the coupling is strictly tuned to Phi, the standing wave mathematics should theoretically lock in and produce that speed of light coherence.
Okay, I need to take a breath here. Because we have taken quite a journey. We built a discrete cosmic universe out of pure math. We've traced the exhaustion of light across distant galaxies. We've trapped that same physics on a circuit board. And we've proven its stability with ruthless null tests.
It's a lot.
It is a lot, but I have to stop the show for a second. Because if you look at the title of the original source document, it isn't called Standing Waves for Circuit Boards. It isn't called Redefining the Cosmic Horizon. It is called Pyramid Resonator Standing Wave for Healing.
Yes, it is.
Which immediately raises a massive blaring red flag. We need to address the elephant in the room right now. How does a perfectly tuned RF circuit board relate to human biology? Because the moment you introduce the word healing next to phrases like quantum standing waves or pyramid resonance, you are walking right up to the cliff edge of pseudoscience.
Oh, absolutely.
We are suddenly in the territory of snake oil, crystal magic, and online grifters selling USB sticks that claim to cure ailments with frequencies. It sounds completely insane.
Your skepticism is entirely justified, and frankly, any scientist reading that title would have the exact same visceral reaction. But this is where the text actually shines brightest in its rigorousness.
That's so.
The authors of the TDUFT model are acutely, painfully aware of that exact red flag. And rather than leaning into the woo-woo mysticism, they meet it head-on by establishing the most incredibly strict, impenetrable scientific boundaries I have ever seen in a theoretical paper of this nature.
Let me be absolutely clear to you, the listener. I am mirroring the exact explicit language of the text here. This framework is an investigational research framework. It is not a medical device. It is not a treatment. It is not a cure for anything.
Right.
The text explicitly and repeatedly forbids human testing based purely on this resonator theory. You cannot just build this fine-tuned circuit board, turn the power on, hold it over someone's wounded arm, and claim you are healing them.
The authors draw a hard line in the sand. It is a masterclass in scientific boundary setting. The text states unequivocally that coherence is a physical property of the circuit. It is a measurement of voltage and phase on a PCB.
Okay.
Healing, on the other hand, is a complex biological endpoint involving thousands of cascading cellular variables. And the authors state you cannot magically leap from a clean circuit measurement to a messy biological endpoint without walking a grueling, deeply skeptical path of empirical validation.
So if they acknowledge the absurdity of the leap, how do they propose actually walking that path? They don't just say don't do it. They lay out a mandatory, uncompromising 5-stage validation sequence.
Yeah.
You cannot even look at step 2 until you've undeniably proven step 1 with data.
Exactly. Stage 1 is device physics. You have to build the physical device, perform all the rigorous null tests we just discussed,
The broken pyramid, the random coupling.
and prove undeniably to independent physicists that your specific piece of hardware actually creates the stable Phi ratio standing wave. You have to prove the physics exists outside of the math.
Once the physics is locked and verified, you are allowed to move to stage 2. Phantoms. For anyone unfamiliar, a phantom isn't a ghost. In medical physics, a phantom is a physical object used as a stand-in for human tissue to test how energy interacts with it. So you don't jump to testing on living cells yet. You use non-living physical targets, like a standardized thermal gel or an electrical proxy material. You map the field geometry. You prove that the device delivers a consistent, measurable, reproducible energy exposure to a target area without the field drifting, spiking, or simply frying the target with raw heat.
If and only if the phantom mapping is clean and stable, you proceed to stage 3, cell-free testing. Notice we still aren't touching anything alive.
So what are we testing?
In this stage, you expose raw chemical reactions or fluorescent proteins in a test tube to the standing wave. Does the presence of the Phi field alter the chemical reaction rate? Does it change the fluorescence intensity compared to a non-Phi field of the exact same power? You are looking for a raw material response, completely free from the unpredictable complexity of a living cell membrane.
And only if you see a statistically significant reproducible effect on raw chemistry do you finally earn the right to advance to stage 4, preclinical biology. Here, you are finally testing on living cells in petri dishes, and the text demands absolute scientific ruthlessness at this stage.
The authors specify that you must use predefined quantitative biological endpoints. You can't just shine the field on a dish of cells and have a researcher look through a microscope and say, well, they look healthier to me. That is how bad science happens.
So what do they measure?
You must measure a specific, undeniable metric. For example, the exact rate of wound closure in a cell culture, the measurable change in calcium ion signaling across a cell membrane, the parts per million concentration of a specific inflammatory marker.
And most importantly, the test must be completely double-blinded and randomized. The technician operating the physical device cannot know if it is tuned perfectly to Phi or if they are operating a sham control device.
Exactly.
The biologist analyzing the cells afterward cannot know which sample received which exposure. Which brings us to what I think is the most intellectually honest part of the entire paper. The biological null hypothesis.
Oh, this is crucial.
The text basically admits right up front that the device probably does absolutely nothing to biology. The burden of proof is entirely on the wave. The biological text is simply this. Does a perfectly tuned Phi-weighted field produce a measurable effect on a cell that an equal power non-Phi-weighted field does not?
That is the crux of the entire biological argument. If you hit a dish of cells with 1 watt of equal ratio, standard RF noise, the cells will heat up slightly due to the energy.
Right.
If you hit them with 1 watt of the highly structured Phi ratio standing wave, they will also heat up slightly. The biological null hypothesis says there will be zero difference between those two outcomes. It assumes the cells don't care at all about the elegant phi ratio or the math of the cosmos. They only care about the raw wattage hitting them.
And the text explicitly states that until that null hypothesis is undeniably shattered by blinded, randomized, ironclad data. Wait, let me rephrase that. Until it's shattered by data, the biological effect simply does not exist. It remains pure, unproven theory.
And even if you do manage to shatter the null hypothesis, if you run the perfect experiment and find that the phi wave actually does trigger cellular regeneration, you still aren't done.
No, you are not, because of stage 5, independent replication.
Exactly. Even if you have the data, you must hand your device blueprints, your raw cell protocols, and your findings to a completely independent, potentially hostile third-party laboratory. And they must be able to reproduce your exact biological results from scratch.
Only then, after surviving the gauntlet of physics, phantoms, chemistry, blinded biology, and a hostile replication, can you even begin to whisper the word healing in a serious scientific context.
It is a very long road.
It is an incredibly satisfying grounding conclusion to such a wild, theoretical ride. We started out redefining the cosmos and ended up staring into a petri dish. But the rigorous, skeptical logic held firm the entire way.
It really did.
Let's summarize this massive journey we've taken together today. We started with a theoretical universe, wiped clean of circles and pi. We rebuilt reality entirely out of a finite, discrete lattice of 5 points and 8 strings.
Right?
We saw how assigning the mathematically perfect golden ratio to those strings allowed a dynamic standing wave to resonate, perfectly carving out the precise, pure integer of the speed of light from raw geometry.
And then we went to space.
We applied that wave's friction to the fading light of distant galaxies, establishing blackout radii not based on the expansion of space, but on the simple mechanical exhaustion of the lattice vibration itself. We took that cosmic math and brought it down to a physical workbench, detailing exactly how to trap that standing wave inside a printed circuit board using inductors, capacitors, and ruthless null tests to prove its stability.
And finally, biology.
And finally, we outlined a rigidly uncompromising 5-stage scientific framework to determine if that mathematically trapped wave can actually interact with the messy reality of living cells.
And this brings us to why all this matters to you, the listener, whether you are a physicist, an engineer, or just someone who is insanely curious about how the universe works.
Yeah, why does it matter?
Whether or not George James Ducas's specific TDUFT theory ends up upending modern physics or revolutionizing biology is almost secondary. What we've explored today is an absolute masterclass in how to construct a falsifiable, rigorously structured hypothesis.
That's a great point.
It asks us to fundamentally change how we view the void. It asks us to look at the geometry of the universe, not as an empty passive theater where planets and photons just happen to exist, but as an active, vibrating, mathematically precise lattice that dictates the very rules of reality. It beautifully bridges the gap between the most abstract topological mathematics and the most rigid empirical laboratory protocols.
It is a stunning piece of theoretical architecture. And I want to leave you with a final thought to mull over as you go about your day. A thought that builds on everything we've discussed, but pushes it just one step further into the unknown.
Okay, let's hear it.
If this model is right, if the foundational constants of our universe, like the absolute speed limit of light itself, are truly just the byproduct of a specific geometric ratio, vibrating on a finite lattice, what happens if we build a device that vibrates with a completely different geometry?
Oh, that is interesting.
If the phi ratio gives us the speed of light as we know it, what does a different mathematical knot give us? Could we theoretically construct a highly powered, localized pyramidal coherence device that vibrates with an entirely alien geometry, and in doing so, artificially construct a localized pocket of space right here on Earth, where the speed of light or the fundamental laws of physics themselves operate under entirely different rules?
That is quite the thought experiment.
Something to think about. Thank you for joining us on this deep dive.